on section 3.5, the chain rule. So first we'll define the chain rule, show how it works, and then we'll give some examples. So what the chain rule says is if we have a composite function, f circle g of x, f composed g of x, then we're going to break this composite function down. We have an outside function called f, inside function called g. The chain rule says to differentiate the composite function, you need to follow these three steps. First, differentiate the outside function, get f prime of x. Then evaluate f prime at the inside function to get f prime evaluated at g of x. G of x is left alone. G of x doesn't get differentiated yet. So differentiate the outside function, plug in the inside function as an input, and then last step is to multiply the derivative by this whole expression, f prime of g of x, by the derivative of the inside function, g prime of x. And then we get our final answer, f prime of g of x times g prime of x. Conclusion is that h prime of x is f prime, the derivative of the outside function, evaluated at the inside function, left alone, times the derivative of the inside function. Here's an example. Let's say our inside function is just any generic function, but the outside function is a power function, x raised to the r. From a composite function, g of x to the r power. And recall the power rule says the derivative of the outside function is r times x to the r minus 1. I have an animation on YouTube actually showing this. R comes down, and then you replace the exponent with r minus 1. Now we evaluate at the inside function, so just plug in, so just replace the input. This says f prime takes an input to r constant times the input raised to r minus 1. Instead of taking x as an input now, it's taking g of x as an input. So r times the input raised to r minus 1 power. Finally, we multiply by the derivative of the inside function. So it's because g of x was a generic function, multiply by g prime of x, and we get f prime of g of x, this should have said times g prime of x, is r g of x to the r minus 1 times g prime. Here's an example, x squared plus 1 to the third power. Outside function is x cubed, and its derivative is 3x squared, just from the power rule. 3 comes down, replace the exponent with 3 minus 1, which is 2. The inside function is x squared plus 1. Its derivative is 2x. 2 comes down. X to the 1 power is just x. So we're just left with 2x. We already differentiated the outside function to get 3x squared. So we already did step 1. Step 1 was already taken care of here. Now we're going to plug in, instead of x, so f prime takes an input, spits out 3 times the input squared. Now it's going to take, instead of x as an input, it's going to take the inside function x squared plus 1 as an input. So f prime of g is going to be 3 times x squared plus 1 raised to the second power. Step 3, we multiply by the derivative of the inside function. We already saw up here g prime is 2x. So we multiply f prime of g of x by g prime of x to get 3 times x squared plus 1 squared times the derivative of the inside function. The inside function is 2x. We can bring it to the front. 3 times 2x is 6x. So we're left with 6x times x squared plus 1 squared. Here's another example. The derivative of an exponential function. Let's say the outside function now is e to the x. And the inside function is a generic function, any function you want. H of x is e to the g of x, it's a composite function. Step 1 is to differentiate that from function. We've seen before the derivative of e to the x is itself, e to the x. Step 2, we evaluate f prime at g of x. So f prime, instead of taking x as an input, takes this generic function g as an input. So instead of raising e to the x power, we raise e to the g of x power. We get f prime evaluated at g of x is e to the g power. And now we're going to multiply by the derivative of the inside function, g prime of x, to get f prime of g of x times g prime of x. We already saw that was e to the g of x times g prime of x. And we conclude the derivative of this function is e to the g of x times g prime of x. So you can remember this by saying, well, if a function looks like e to the stuff, the derivative of e to the stuff is e to the stuff times the derivative of that stuff. Let's look at this in action. Let's say we take e to the sine x power. Outside function is e to the x. Inside function is sine x. Its derivative is cosine. Derivative of the outside function is e to the x. We evaluate at the stuff at sine x, so we get e to the stuff is e to the sine x. Now we just need to multiply by the derivative of the inside function, by the derivative of the stuff. Derivative of sine, which in this case is cosine, and multiply. So the derivative is going to be e to the sine x times cosine of x. Okay, and then here's a table of some more functions. You might see this comment. It's important that sine squared x does not mean sine of x squared. It means sine x in parentheses squared. Derivative of this is 2 sine x times cosine x. Derivative of 3x plus sine x, 10 comes down. 10 parentheses 3x plus sine x, the 9th, times 3 plus cosine x. That's the derivative of the inside function. Here, so the first three are using outside function as a power function, something raised to a constant power. Derivative of the square root of x plus e to the x, that is 1/2 x plus e to the x to the minus 1/2 power times the derivative of the inside function. Derivative of x plus e to the x is 1 plus e to the x. Here, the outside function is e to the x. Inside function is 5x minus 3. Derivative of 5x minus 3, or any constant times x plus a constant, is just that constant. Derivative of a function whose graph is a line is going to be the slope of that line. That is the coefficient of x. So here we're going to get h prime of x is going to be 5 times e to the 5x minus 3. Here, h of x is e to the x plus 1 over x minus 3. So again, it's e to the stuff. Derivative of e to the stuff is e to the stuff times the derivative of that stuff. Now here, in this case, notice to differentiate this exponent, the function that was in the exponent, we needed to use the quotient rule. We've seen the quotient rule in Monday's lecture. Derivative of x plus 1 over x minus 3. Derivative of the numerator is 1. We leave the denominator alone. And then we subtract by the derivative of the denominator, which is also 1, times the numerator left behind. So we're left with x minus 3 minus x plus 1. That's the same as x minus 3 minus x minus 1. The x's cancel. You're left with minus 3 minus 1, which is negative 4. And of course, you're dividing by x minus 3 squared. So it's e to the power times negative 4 over x minus 3 squared. What that means is, so again, just in summary, the derivative of e to the stuff, e to the function, is e to that function times the derivative of that function. Okay. So this isn't accurate. This should have been April 1st, not March 27th. Okay, so we'll see a little bit more about the chain rule later on. We'll apply this to logarithms on Friday's lecture. Don't forget about your quiz also on Friday. It's April 3rd.